All right, so for today what we're going to do is we're going to be looking at something called exponential growth. In the past we've worked with exponents, positive or negative, but we're really going to see how some of these things go into graphs that we haven't seen before. So first of all, let's take a look. It says compare the difference between a linear function and an exponential function. Now, if you'll remember, a linear function was of the form y equals mx plus b. And when we look at a table, we can tell it's a linear function because you'll notice that to go from each one of these numbers, I'm going up consistently by adding 1. If I take a look at the y values, you'll notice that I'm adding 3 each time. So you'll notice that I am adding each time to go from one value to the next. Well, let's take a look at an exponential function. You're going to notice that it's of a different form. Y equals ab to the x. Right? And if I take a look at this function a little bit closer, you'll notice that my x values each time is going up by 1, so it's not different from the linear values. But you'll notice that the y values are different. In fact, each time I multiply the value by 3. I don't add it, I actually multiply it. And that's where we start with a really small number, and we end up a lot bigger in the end. So let's take that fact and let's go a little bit further. We're going to write a rule for each one of these functions. Again, we're going to have it in the form y equals ab to the x. When we look at this, we're going to look at the a first. The a is the y-intercept. So I'm going to take the y-intercept, and that is the y value that is paired up with the 0 for x. So a is your y-intercept. So I'm looking at the 0 for x and I'm checking to see what y is. So this ends up being y equals, I'm going to plug in -1 for my a. Now I'm going to look at my b. To find my value of b, what I'm going to do is I'm going to take a look at my y values again. What do I do to each number to get the next? And you'll notice that I'm multiplying it by 4. So that number 4 ends up being my b value, and it's to the x power. And that's how you find a function rule for an exponential. So let's go down here and let's take a look at this. Another example. Y equals a b to the x. Again, I'm going to look for the x value where it's 0. My y is 27. So x ends up, or a ends up being 27. Now I'm going to look at my b value. Again, I'm looking at these values to see how they change. You're going to notice each time I'm multiplying it by 3. So it's going to be 3 to the x. And there is my exponential function. All right, now let's go to this type of question. This is where we're going to graph. We're going to graph y equals 2 times 3 to the x. We're going to identify the domain and range. And then we're going to compare it to y equals 3 to the x. Now we've done this stuff before. We go ahead and we make a table. So you notice that I'm going to set up an H table. In the first table, I'm going to put in the smaller function. And I'm going to plug in values that we did for the linear equations before. Plug in -1, 0, and 1. So I'm going to plug in -1. Don't use your calculator on this. You should be able to do it without. You'll notice that 3 has a negative number, and so it becomes a fraction. The 3 comes down below. I'm going to put in the 0. Anything to the 0 power is 1. And then I plug in my 1, and I end up with 3. So that's my first table. Now what I'm going to do is I'm going to look at the other function. Y equals 2 times 3 to the x. I'm going to plug in the same values, so -1. You're going to notice that there is more work involved in this because it's a 2-step equation. I get 2 times 1/3. 2 times 1/3 is 2/3. Again, you shouldn't need your calculator for that. You should be able to do it without. I'm going to plug in 0. And then finally I'm going to plug in 1. So I got both of my tables right now, and what I'm going to do is I'm going to plug this in to my graph. So if I take a look at my graph, in my first table, I had -1 and 1/3, so it's about right there. I had 0 and 1, and I had 1 and 3. And you're going to notice when I graph it, I never touch the x-axis. I never touch it. I don't go over it. It's just hovering above that. If I look at the next function, I had -1 and 2/3. I had 1 and 2, and I had 1 and 6. You're going to notice that this blue line, again, does not cross the x-axis, and it's hovering just above the black line. And in fact, if I take it, it stretches way up quicker and faster than the blue one, or the black one. And so if I go and take a look at this, my blue line is going up quicker and faster than my black line. So if I go back to the next step, of course, plot the points I did, draw a smooth curve, I did that, compare the two graphs, okay? If I take a look at the black compared to the blue went up quicker or stretched. So it's a vertical stretch. Okay? If the blue line was underneath the black line and didn't go up as quick, that would be considered a vertical shrink. And as you do your homework and check your answers, you're going to notice that answer. So just be aware that it's not always a stretch. It could be a shrink. Now let's take a look at the domain and range. The domain, when we did it, you'll notice that I was able to choose any values I wanted to. I chose -1, 0, and 1. I could have chosen fractions or decimals. It could have been any number that I want. So for the domain, we put all real numbers. And you know, Mrs. Medvick, all the numbers are real. Like, seriously. There is another number system out there called the imaginary numbers. We see that in Algebra 2. We do not see it in Algebra 1. So for our purposes, they are all the numbers we work with, but they are a set of real numbers. So you want to make sure they include that. When you look at the range and the numbers that we have here, you'll notice that I said we're never going to cross the x-axis. So if you take a look at the y values in the first table and the y values in the blue table, you'll notice that both of them are positive numbers. So the range in this are all positive real numbers. Make sure that you do all 4 steps. When you do your assignments, make sure that you not only are doing the problems, but you're also checking the answers. And that is it for day 1. Tomorrow we'll look at day 2 and see exponential growth in real life situations.